Okay, good afternoon. So let us continue the lesson. Not that much is actually left from set theory, so sooner or later you have to be prepared for the exam, the first exam. Okay. Yeah, let us finish this lesson and then we can discuss probably about a good time for having the first test. Okay, in this subject. So what I want to talk about is another set of laws. They are very famous in set theory and they are called DeMorgan laws, okay? Okay. So DeMorgan laws are actually related to if you want to make a complement of the union or an intersection, yes? So if I give you two sets, A and B, I union them, of course it becomes a new set. I can talk about what happens if I want to make the complement of the result. Okay, so my question is that how the complement of the union of two sets is related to the complements of each individual set participating in that union. Yes, that's the question. And I want to ask the same question for intersection. So in other words, there are two laws, the DeMorgan laws. One of them I want to write it here, and the other one is the same question when I intersect two sets. And I want to take the complement. So what happens here? The answer is that I can take the complements individually in both cases. But something nice happens is that if you are unioning the sets, here it turns into an intersection. And if you have an intersection, it turns into a union. Okay, so it was not that trivial that you just flip in the complement on each. You have to respect this rule that every union should be turned to an intersection and intersection should be changed to a union. Okay, I don't know. We might be able to have some motivations why these formulas are correct, and we can prove it mathematically, of course. So if I want to try to convince myself somehow about this, okay, let us just do two copies of the same Venn diagram. This is just intuitively correct. So let us consider that I have a set here A, another set here B. So if I ask you where A union B intersection is, so you need to find a union. Where is a union? A union is everything which is either in A or in B or in both. Yes, so everything here is actually a union. If I want to draw a border around that, so everything inside this red boundary is A union B. And now I am interested to the complement of this. So it means that whatever is outside this red boundary but inside my rectangle, that is A union B complement. So if I want to color that part, so this blue part that I am just doing now is actually the left-hand side. Yes, is that understandable? So this is the left-hand side, which is A union B intersection. So I union these two first. It becomes inside this red boundary. So whatever is inside the rectangle but outside this red boundary would be its complement, which would be A union B complement. But if I want to convince me that the same thing happens here, let us see. It might be a little bit harder, but I have to try to draw at least an identical picture here, more or less. So A, and then I have B. So okay, let us consider what happens if I want to determine A complement and B complement and then intersect them. So I don't know how should I do that, but let us try my best. So A complement means whatever is outside A. Okay, so whatever outside A, we don't care about anything except that it should be outside A. Yes, it could be, of course, inside B, no problems. But it has to be outside A. Yeah, so this is actually, this green one is A complement. But let me do it the other way around. For B complement means whatever is outside B. Yes, so whatever is outside B, this is also acceptable for this case. Outside B, so I can go inside A, no problems. But I have to be outside B. Yes. I'm not allowed to go in B. So you see that some parts are hatched with just red, some parts are hatched with just green, but some parts have been actually colored with two different colors, green and red. But this sign is intersection, so it means that I am interested in the overlap between the green area and the red area. I don't know, can you convince yourself that the areas that have been colored with two different colors are exactly this area? Yes? Is that clear? Somehow. So you see, I have to, this one is just one color. I have to exclude that. This one has no colors in it. Yes, no colors in it. So this has to be excluded. This has only red color. It has to be excluded because I am interested in both colors. So if I exclude those, what is left is exactly outside this region. Yes, so it means that intuitively this is correct. But if I want to prove it mathematically, what should I do? I want to prove that two sets are equal. There is one standard way in set theory to do that, and that is to take an element on the left-hand side and show that this element is in the left-hand side and the other way around. Yes? So I would say that if I want to prove this mathematically, I would say let X be in A intersection, A union B complement. Okay. Now, I think you can do it yourself, or at least you can help me to write it down. So if from this statement, immediately I can conclude a sentence, a statement. What is that? Yes?
X does not belong to A.
Yes. If X belongs to a complement, it does not belong to the set itself. So this means that X does not belong to the union. Is this clear for everyone? That's based on definition of the complement. But now you are telling me that X is not a member of the union of two sets. What would be the conclusion? What? Yes?
X does not belong to A or B.
No. And. It's important, yes? Because for X to be in the union, it should be in at least one of them. When you say it is not in the union, it is not in neither of them. Because if it was in one of them, it should be in the union as well. Yes? So this is very important. Don't get confused with this and or. So this means that X does not belong to A and. Let me write and here. X does not belong to B. Yes? But if X does not belong to A, it is guaranteed to belong to the complement. And X does not belong to B, it's guaranteed to belong to its complement. Yes? Now you have one single element and you have two different sets. But you know that this single element belongs to both of them. So it means that if you want to, you can conclude that X belongs to where? It is both in A complement and B complement. So it is intersection with B complement. So it belongs to A intersection A complement intersection with B complement. But so I just picked a typical element. I called it X. It doesn't necessarily mean letter X is one of the elements. I just called that typical element X, whatever it is. And I showed that if this element is here, I was able to show that it is also guaranteed to be on the right-hand side. But is this enough technically? It's not enough, yes? Because we have to do the other way around. Because I just showed that whatever is on the left is also on the right, in the right. So it means that the left-hand side is a subset of the right-hand side. But I want to show, no, more than that. I want to show that they are equal. This can happen only if I can do the reverse as well, yes? But the reverse, usually you just need to think about this and change the arrows. Do you think if I start from here, picking an element in the right-hand side, can I go from here to this? Yes, this is clearly reversible. Now that I am here, do you think I can go back to that statement? If X belongs to a complement, it is guaranteed that X does not belong to the set itself. So the same true is that I can go back in this direction. Okay, if I have this, can I conclude this? And an element is neither in A nor in B. So definitely it cannot be even in the union. Yes? So this is also possible. And if this is the case, this is also possible. So you see that double arrow in mathematics is read if and only if. You can just abbreviate it with this one. And this means in mathematics equivalent. So if two statements are related using this conjunction or this symbol, this means that these two are mathematically equivalent. There is no difference between them whatsoever. Yes? Is that clear? So let me just pause the video and give you 2 or 3 minutes. As an exercise, do this one as well yourself. Okay? Not using the Venn diagram, just using this mathematical argument. After that, we can continue. Okay. So let us see how this will go. So here, again, I will do the same trick. I would say even you don't need to write that. So we can just start from here. X belongs to A intersection B complement. So what can I conclude immediately is that X belongs to a set complement, so it does not belong to the set itself. But this is important to understand. You say that X doesn't belong to the overlap of two sets. So what is the logical conclusion out of it? Yes? Yes?
X doesn't belong to A or.
Or. It should be or, yes? So if X does not belong to A, or X does not belong to B. So because if X belongs to, yes, if this is not the case and X belongs to both of them, so definitely it belongs to the intersection. And then everything becomes very clear from now on, yes? X does not belong to A, where it is in the complement. Or X does not belong to B, where is it? It is in the complement. And now you are saying that I have one element, I know that it is either in this set or in that set. But it is guaranteed that it should be in the union, whatever it is, yes? So then this means that X belongs to the union of these two sets. And then again, of course, this is not enough yet. You need to convince yourself that every arrow is reversible. But I think you can immediately convince yourself that this is indeed the case for all these arrows that goes to the right. There is a corresponding arrow that goes to the left. And this means that these two things are equivalent. Saying that X belongs to this set is mathematically the same statement to say that X belongs to this set. So they are exactly the same. Any questions? Okay, in principle, there is one thing left in the lesson, but before doing that, let us practice a little bit about these formulas that we learned, especially the DeMorgan laws. distribution laws and absorption laws. Yes? So let me just write them somewhere that we can refer to them if we want to. So we had distributive laws, yes? So the formulas were, we have A union B intersection. So this is important to remember. You have three sets and two different signs, one union, one intersection, and then you can distribute the union over intersection by writing A union B and A union C. And then number two, you have A intersection B union C is equal to A intersection B union A intersection C. If you remember, I told you that these formulas are two-sided. Sometimes this is given, you want to write this. Sometimes this is given, you need to write this. So you need to know. In this way, we call it expansion. In that way, we call it factorization. We are taking of course, factorization is not a good word because factorization in algebra makes sense because when you write it as a product, each product is a factor. But here I cannot say that A is a factor, but that's the same idea. So these are distributive laws, and then I told you that there is something that you need to be careful about. If you have this situation, but one set is repeated exactly, if you want to do this, it is not wrong, but it goes to a circular argument. It returns back to itself. Yes? In that case, we need to use this absorption laws. Yes? What are they? They are actually, number one tells you that I have this scenario, A union, but again A repeats itself. The answer would be the one which is repeated. And then I have A union, A intersection. A intersection A union B, then it becomes A. And finally, what we learned today is DeMorgan laws, yes? Yes, number one, I have A union B intersection is A union B complement, A complement intersection with B complement. 2, A intersection B complement is A complement union B complement. So these are the rules that we learned before. So let us explore, let us do some set algebra together. So first thing, let me start with the question that I told you, but I couldn't solve it because we didn't know the DeMorgan's law there. So here, let me simplify this expression. So let me write example, simplify. Of course, for simple cases, you can also imagine it in your head. Actually, you did it before I solved the problem. I couldn't solve that problem because we didn't know the DeMorgan laws. But can you again imagine it in Venn diagram and give me the answer? Can you imagine it? If you want to imagine something, if there is no relation given to you between A and B, just draw the most general case. The most general case is this intersection view. So if I ask you A minus B, where is A minus B first? A minus B means the set of all elements that are in A but not in B. Yes, that is A minus B. So A minus B is this part. All the elements that are in A, but they are not in B at all. This is A minus B. Now I ask you again this question, A minus B means all elements that are in A, but they are not in this colored region. Yes, this colored region is A minus B. This colored region is A minus B. Agree? Now I am telling A minus the colored region means all the elements that are in the first set. So all the elements that are in A, but not in the colored region. So what is left for this? Yes? A intersection B. So this red color, if I ask you what is another name for this red color, you would say that all elements that are in A, but not in the blue region. Yes? On the other hand, there is a name for this. What is the name for this? A intersection. So intuitively, using the Venn diagram, this is really important to understand. If you don't understand, please let me know so that I explain. Is that understandable for everyone? Okay, so we know the answer to this should be A intersection B. Okay, but let us do some algebra now. So, okay, I forgot to write a very important theorem. What was that? The formula that relates the difference to intersection. Do you remember what was that? A minus B is equal to?
A intersection B complement.
Yes, exactly. Thank you. So this, it was very important. I forgot to write, but this is understandable. Okay, so now what I can do, I don't know what do you suggest, but let me change my color to the answer. This blue one is the answer. I will copy and paste this one. Okay, let me, for the time being, keep this, because this pair of brackets gives the priority to this. So this means that I would write A intersection B complement. Yes? So this pair of brackets tells me that I need to do this operation first. I did it using this rule, which is, I told you, the only important rule when it comes to subtraction. Yes? Understandable? Now, again, I have another subtraction, so I have to use the same rule. So how should I write it? This rule tells you that repeat the first set, change the difference to intersection, and complement the second set. I will do the same thing here. I write the first set, I change this to intersection, and I complement the second set. Yes or no? Understandable? But now you see that I really need DeMorgan law, one of them, to be able to do something for this one, which we didn't have before. This is why I stopped solving this for you. So now A intersection, according to this rule, the second DeMorgan law, if I have intersection between two sets and I want to make complement of the answer, I can complement each component, but I need to change intersection to the union. So what I do, I write A complement, I write the second set, B complement, another complement, and then I change this union, this intersection to the union. Yes? So even though this, by the way, if they were number, what was the answer? If A and B are numbers, what's the answer? What's that? If you don't answer, we have to start Math 1C. Yes? If A and B are numbers, what's the answer of A minus B? The answer would be? Come on. The answer would be? A minus B. The answer is? A minus A plus B.
Yes.
This minus sign goes here and there. And then this one and that one are cancelled. The answer is B. This is the difference. Be careful. The algebra of numbers is really, really different from the algebra of sets. The answer would be A intersection B. Let us continue. So it is not that simple as that one. Okay, so what can I continue? First I get rid of these complement. So it becomes what? A complement union B. But it seems that it becomes worse, yes? Because now what should I do? What you need is on the board. What type of rule is this? If I want to continue, name it. Yeah, distributive law, yes? Because I have three sets, A complement, and B. One is union, intersection, the other one is union. So that is which one of them? This is the second one. A is playing the role of A, that's good. But here A complement is playing the role of B. B here is playing the role of that C. And none of them is identical. None of them is identical. So it means that this is not the absorption law. This is indeed distributive law. Yes? Let us distribute that. What happens? Can you read it for me? What is the first pair of brackets? So I will have two pairs of brackets. A complement. And what should I write here?
A intersect
B. And what would be the sign in between? Union. Yes? But I have another rule for A intersection, its complement. What's that? A intersection with its complement. What is the set? The empty set. So this would be the empty set. Every step should be written down, by the way. You cannot just drop that. So then union, A intersection B. But what is the answer to this? I have a set. Don't care about its name, whatever it is. I am unioning it with the empty set. What would be the result? The set itself. So that prediction was actually correct. But this is the rigorous way of doing that. So that algebra of sets might be complicated sometimes, yes? And it is different from the number algebra. So if you guess that the answer would be B, it is wrong. The answer is A intersection with B, yes? So be careful. There is a very big difference, even though there are some similarities sometimes, but not always the case. Okay, so let us check your intuition. What happens if I interchange them? Before calculating, answer it using a diagram, okay? So my question is this for you. So I start with A minus B in pair of brackets, and then minus A. So the question is this. I want to simplify this. Do you have any idea before doing the calculation? Do this practice. It will improve your intuition about the concept of sets. A minus B minus A. Yeah, imagine it in your head first and then give the answer and then try to prove it mathematically. Don't do the calculation. Imagination is the answer is very simple. By imagining what is happening. Could you find the answer? Yes? Dylan, do you hesitate to say something?
Minus A interesting.
There is no minus in the set theory. Is that understandable? There is no minus a set. We don't have the notion of minus a set. Be careful. Yes. Yes. It is the empty set. But it is not hard to imagine why it is hard for you. Let us just double check. So I told you that if you want to draw a diagram for two sets and there are no conditions imposed on these two sets, draw them in this way. Okay? In the pair of brackets you have A minus B. Where is A minus B? We did it actually right now. This blue part, do you agree with me, is A minus B. Yes? But now, what is the meaning of this? This tells you that whatever is in here, but not here. So it means whatever in the blue one, which is not in A. Can you find something which is in the blue one and not in A? You cannot find that, so that's empty. No, I think so. If you really understand, please nod your heads. Yes, do you understand? Yes, don't look at me like that, okay? How could I feel that you understand or not? Okay, so A minus B is the blue set. Forget about set. It's the blue region. Now I am asking you, find a point in the blue region which is not in this circle of A. Can you find something like that? Everything in the blue region is automatically in the circle of A.
Yes.
So it's empty. Nothing you can find. So we imagined, so our answer is clear. The answer to this should be the empty set. Yes? Dylan, do you have problems?
Oh.
Yes, do you have problems? Okay, just talk about this so we can solve it.
Could you just repeat it?
Yes, yes. What is the meaning of the difference of two sets? When I say forget about A and B, let me have a box minus a circle. I have two sets, I want to subtract them. What's the meaning of that? Which elements do you choose to put in this set? So probably you have forgotten the definition of the difference. We define the difference of two sets. Might be, I don't know, you were absent I think one session.
Yeah.
So I don't know if you are absent for this session or not. If I have the difference of two sets, it's the one that I told you in the book, it is written by this symbol. But instead of this symbol, I use the normal. It means all the elements in the set of universal set such that that x belongs to the first one and does not belong to the second one. This is the meaning of the difference of two sets. So when I say I have a set A and a set B, color A minus B for me in that picture, you will go and color those parts which are in A, but they are not in B. Okay? So if I want to color everything in A, I am also coloring these parts, but these parts are also in B, which I have to exclude according to the definition of the difference of two sets. So I just care about those parts in the circle of A which are not in B. Then what is left for you, do you agree with me, that would be this blue area.
Yeah.
So that is the meaning of A minus B.
Yeah, I understand.
Okay,
It's
but-
minus A.
Okay, but now A minus B, if I ask you to show A minus B in this picture, you will point to this blue region. So blue region is a region, and A, where A is the whole region here.
Yeah.
Now I am asking you, what is the difference between these two? It means that find all elements that are in the blue region, but they are not in A. Can you find such a point? Nothing is found, so it is empty. Is that understandable? Yeah, if you don't understand, please ask me, okay? You don't need to actually shy or something, but this here, we are here to solve the problems. But hopefully you understand that this is supposed to be the empty set at the end. But the algebra might be a little bit complicated. The algebra here is very simple, by the way, but I want you to tell me where should I start from. I want to simplify this expression. Be careful again. Was it, yes, was it this one or A? No, it was A. So, be careful. If A and B are numbers, how do you do this algebra? You open this pair of brackets, and then you have a minus A. You cancel this one with that one, you get minus B. There is no meaning. If you remember, if you go back, if I give you a set and I ask you what is minus a set, we haven't defined that at all. Yes? The operation that we can do on one single set is the complement operation, not minus operation. Yes? Yes, Dilan, or not?
Yes, yes.
Yes, okay. So, let us see the answer. What is the answer to this? What I have to do first, let me write with blue, this is the solution now. I have to do this one first, but if I want to do something with subtraction, and I want to be able to continue, this is the good one. Because I don't know that much about difference, but I have a lot of rules about intersection. So let us just do that. I will take this one, and instead of that, I will write the first set. I change this to the intersection. I put this as the complement. Let me keep this one for the time being. Yes? But again, I can use this rule because I have another subtraction. So this tells me keep the first one, change the difference to intersection, and complement the second set. So this is my first one. I keep it. I change this one to intersection, and I complement this. Yes or no? Okay, but what is the name of this rule? How should I continue from now on? Let me ask you in this way. Is it distributive law? No. Why? Even though I am facing three sets, but both of them are intersection. In the distribution law, one of them should be union, the other one should be intersection. So it is not the case. So this is associativity. Associativity and commutativity probably. So associativity means that, for example, let me, if I want to be very pedantic, I have to write everything. So I can commute these two. Yes? And then I can take this pair of brackets and put around them. From here to here is commutativity. Putting this pair of brackets around these two is associativity. So then what happens? B complement will be left alone. Intersection A complement. Yes? But now if I ask you what is the answer to this, you know. What is that one? Is the empty set. And now I have one set, whatever it is not important, but you are intersecting it with the empty set. What is left? The empty set. So as we guessed, the empty set was correct. But this is the rigorous way of doing it. Yes?
Must you show the step in between when you change?
No, not that much. But I want you to understand. I could jump from here to here. Yes? But I want you to understand two properties are really involved. Commutativity and associativity. Is that clear? Yes or no?
Yes.
Okay. Now, let me ask you this one. What is your intuition about this? What do you think about this one? Answer me quickly. What happens if they are numbers? Please answer this correctly, okay? If they are numbers, what would be the answer? No. That is why I begged you, please answer correctly. If they are numbers, yes, you are making a minus sign mistake over and over again. Don't do that. Minus sign goes here, it becomes minus a plus b. It becomes 2b minus a. But the notion of 2b, do we have 2b in the set theory? No. So we can define it, but it is not in your lesson. So I cannot multiply a set by a number. Of course I can, but not at this level. So we haven't defined how to multiply one single number by a collection of elements. Yes? Okay. So, but they are not numbers, they are sets. What is your intuition about the answer by Venn diagram? Who said B? Yes, I think that's correct. Everyone agrees with that? So why is that? Let me just draw another diagram for you here, because it's really important. By the way, most part of your lesson is to improve your intuitive skills here. But I myself also prefer you to learn a little bit about algebra, because that's a rigorous way of doing that. Every now and then I see that some abstract questions in the book, but most of the time they are asking you about Venn diagrams, intuitive ideas about sets. But I don't believe this is beyond the way of your understanding. You really understand, so why not? Okay? So why this is B, as Dennis actually said. So here we have A, here we have B. Again, I have A minus B in pair of brackets. So let me just color it as before. This is the blue region. So you need to interpret it. Forget about the names and the figures and the shapes. So this tells you that. Can any one of you tell me what we are interested in this set? In English.
Whatever is in B, but not in
Not in?
A.
No.
But not in the
Not in A minus B, thank you. Yes? So whatever is in B, but not in A minus B. Yes? But A minus B is the blue region, so I can say that whatever is inside this circle, but it is not inside the blue region. So what is left for you? The whole B is left for you, yes? Because whatever inside B is automatically outside the blue region. So what you guess the answer is B. Okay? Okay, I want to wait for you. Just do it algebraically. And then I want a volunteer to come here, yes? Two, yes, science program, and then, now one technique. Okay, Dimitri, are you ready?
Yeah.
Yes, please. Yeah, please explain everything what you are doing. Yes, you can take whatever you like. I think blue, if you take blue, that would be good.
Okay.
Thank you.
Where should I just erase it?
Yeah, you can. Yeah, clean this one because no one needs that.
So we have B minus A minus B.
Yes.
We can express that like B minus A intersection B complement. Then we can express that in B intersection A intersection complement.
Thank you.
And that we learned today is the
Yes.
DeMorgan's law.
Write all these steps. Yes.
B intersection A union A complement. I mean,
No, please write the steps. Complement.
complement.
Another pair of bracket. Another parentheses close. Yes. Yeah, please, if you want to solve these questions in the exam, respect all the details, okay? Yes?
And now, because we have B and B, it's the absorption law,
Yes.
so that should equal to B.
So, everyone understands the last part, even though it looks like a distributive law, because we have three sets involved, one intersection, one union, but be careful, if you want to use distributive law, that would be a circular argument. It doesn't give you something interesting to you, okay? But immediately you realize one set is identically repeated. So this would be absorption law, so the answer would be just B as we predicted. Yes, thank you very much. Okay, now let us start solving harder questions, okay, to see how it works. By the way, why we learn algebra is because might be the algebra here is more complicated than visualizing this. Okay, it was easier to visualize it immediately than go into this algebra or the algebra before that. The first thing is that this is not considering all cases. This is a particular case in which A and B intersect. We can consider, I don't know, A and B does not intersect. A is inside B, B is outside, B is inside, A is outside. If you want to really visualize it, you need to convince yourself of all possibilities. Which we didn't do that, we just did one of them and then try to guess based on that one. Another problem is that if this expression turns out to be more complicated, visualizing this becomes harder and harder to consider all scenarios. This is why we cannot just rely on our intuition, we have to have a systematic method to do the algebra. Okay? So this is why you will appreciate this if we go to a little bit harder problems, okay? So for example, let me just write this one for you and ask you to simplify. I want to wait again for you, okay? Here, I would say that don't try to visualize it. Of course, that's also a good practice. If you want to do it, just do it. But here, I prefer you to do the algebra. So this is the case. I have A intersection A complement union B, and then this combination is union with this combination. B, I hope that everything there is right. So let me see. Before writing it, make me, yes, that seems correct. I want you to simplify this. So you see, we are improving our skills. If they were numbers and they are addition and subtraction and multiplication, you don't have any problems with simplifying such an expression. But now we are practicing to master this new algebra as well. Let me double check everything. A intersection A complement union B. That's correct. Union B intersection A complement union B complement. Yes. I want you to simplify this. And if the answer in the book is correct, you can just tell me the answer. And if it was correct and you want to come here, you can come here and solve the problem. So if you don't mind, let me write another one. So if you solve, don't waste the time. The people who solved it, just they continue. Otherwise, let me write something for you here, okay? Okay, so the people who finish this one, they can start working on this one. Let me also write another one. Might be this is complicated, but let us face it. Yes, yeah, these are three problems. I think the last one would be harder, I don't know, but I don't think they are hard actually. This might need a little bit more work. Let us see how it goes. Okay, so Dennis, you said that you want to come and solve. Yes, please come. Thank you. Yeah, please listen to how is it going. And I would appreciate if you also can explain. Thank you.
Yes.
By the way, I forgot to say that you will be on YouTube. No problem.
I first used the distributive law and to write it like this.
Okay,
So I let
yeah, so you did two distributive law, yes?
exactly.
one in the first pair and the other one in the second pair. I checked everything is right, so if you don't understand something, please let me know.
And then this
The last one, no.
is just the empty set. There is
Yes.
no intersection. And so is this.
By the way, this way that Dennis writes is also acceptable in the exam.
What?
If the expression is too long, you can just write that this is the empty set and go to this is also I accept that one. Okay? Because clarity is important.
So that's what I got. And then I just took away that, because union with the empty set is just the set itself.
Yes.
So I did it like this.
The third one is not the empty set. No, no. Alright, so this is important now. Okay, I want you to check. So most of you probably could come up to here, which is now the correct one. But now can you explain how do you want to proceed?
Yes, I used the distributive law again,
Yes?
but this plays the role of A.
Okay, so you are doing that.
Yes.
I was thinking in a different way. So just you continue this way, that's correct. But then I tell you my alternative way. Okay? Sometimes this way is inevitable, so you have to learn this.
And I changed it to intersection.
Yes, yes. Yeah, you made a small mistake in the second pair of brackets. What you are distributing in, can you just explain it again? Yes, so you distribute it, you wrote it correctly in the first one, and then you distribute it again.
Yep.
So this is intersection. Yes? No, your solution is correct, but is that understandable now?
And then
Is that understandable for yourself?
yeah.
Yes, because let me explain. This is not the way I wanted to do it, but that is also correct, and sometimes it is inevitable to do it in this way. What Dennis actually tell is that let me take this one package, let me call it curly A. And then I have curly A union the intersection of two sets, so that would be again distributive law. And then she's distributing this here, which you wrote this, and then intersection distribute this one here. So actually that's completely correct. Is there someone doesn't understand that? So she actually taking this as one single set in her head and then distribute this. That's correct. Okay, and then
A intersection B
yes,
is a subset of B,
yes,
and the subset union it's just B.
B, or that's completely correct. But what is the name of this rule?
It's
absorption law. Yes, but this is the proof she made. Yes. So B, thank you.
And then intersection B union
Yes.
A. Like that?
No.
So yeah. Is this?
No. Just look at it here again. What is this law again? Distribution law. But you are distributing from left.
So A.
So this becomes everything is okay. So just have these two pair of brackets, a bigger one. Okay, but now you are distributing it here. Can you do that? You can imagine in your head this is on the left hand side. Yes, yes, yes. And then intersection? Exactly. Okay, then what happens?
Then this is the universal set.
Yes. And then universal set intersection with every set is?
The set itself.
The set itself. So just go to the next line. Okay, it's 99% finished. And what's the answer to this?
A union B is A complement union B, and then B intersects.
Yes.
It's B.
It's B.
Because
Yes,
B is
yes, exactly. Or again, another way to say this is also absorption law.
Yes.
Yes? Okay, thank you very much. Thank you very much. So, this idea was great here, but here you could do it much simpler. And I want to ask your opinion about that. So, by the way, 2-0, yes? Now technique 2, not 2-0, yes? Okay, now, this idea is very, very nice to remember. Sometimes it is inevitable. But here, I could do it simpler. So I want to hear Dimitri. Do you have any idea?
Yeah, I mean you can take B out.
Yes. If you have factorized, that would be easier in this case. But in the other cases, might be this is a different name. Then this is the only way that one can do. If you see here, I have A intersection B, B intersection A complement. If instead of B, it was C, the method that you have done is the only method. But here in this case, I can have a different idea. So let me put a star here and write my answer here. Okay, from here I will write it in this form. So what happens? I have B intersection, another B intersection here. So you pull B intersection out. So what is left? Can you tell me, if I pull B intersection out, what is left from the first? It is A. What is the other one? A complement. What is the sign between them? U. Yes? And if I ask you what is the answer to this, it is just a universal set. B intersection the universal set, and this is B. So it was much simpler in this case. Yes? Understandable this one as well? Okay, so Amanda, you said what is the answer to this? That one is correct. But what you said about this, if the book is correct, I don't know. What you said about this one, what was that?
A complement intersection B.
That's correct.
Okay.
Yes, that's correct. But there is a better name for that. This is why I didn't realize what you said. The book has written in terms of difference. Okay, that's why when you said, I didn't realize that in that way. Okay, now do you want to solve it?
Yes. Amanda.
Yes? Did you solve it, Dimitri, as well?
I saw it also.
Okay, good. Others, please participate in this nice competition, yes?
I can solve this.
Yes, please.
A complement.
Yes, no problems. You want to solve the second one?
Yeah.
Yes, please.
Yes.
What is your name?
Amanda.
Nabi, yes. You will be on YouTube, okay? Yes. Yes, you can remove. Any questions regarding that? By the way, I can just assure you that even a university student doesn't know how to do these things. That's completely for sure. Unless you go to mathematics department or probably computer science. Yes. So actually, you can do something that probably according to the standards here, this is above the high school level. But this is not hard. Yes, you could manage it. Okay, but so you are learning a new algebra. you have to practice so that your brain becomes ready for it. No, first write this one itself. You just copy and paste everything so that when you solve, everyone can see. Yes?
So first I use this method.
Yes?
This
Yes,
bracket.
yes.
So you copy this first set,
Yes?
you intersect,
Yes?
and you complement the second set.
Exactly, thank you.
Then union, I copy. You don't have to copy this. I use DeMorgan's law.
Yes, yes?
Is it the second? It's the first one, yeah.
Yes.
So first one. So what you do is that you write the complement. No, you complement.
Yes, please write the details, yes. Don't do it in your head, okay? This is the good way of writing in the exam. If you want to do it quickly, no problems. But if you want to write it in the exam, write all the details, please.
And you intersect, and then you complement this as well.
Yes,
So we got rid of this.
yes, yes.
And then you can write A complement, B complement, union, and B complement is B,
Yes,
intersection A complement.
yes.
Now we
A
can
very small flaw is that, okay, you have to put those pair of brackets. This is a have to, because we have different signs. Yes, it was intersection and union, so you have to make this clear. Yes.
and then we see we have both A complement here and in this bracket, so we can factorize that out.
Exactly.
So A complement, and what follows is the intersection,
Yes,
and then in brackets we got B complement left,
yes.
union B. Union B, brackets, and then you see B complement union B is B complement.
No, no, no.
No. Oops.
Yeah, you know that. Yes.
It's,
No, that's correct. Everything was correct. Don't click. But what is
it's the
B?
universal
The universal
set. It's the
set. Yes.
universal set. So B complement union B is the universal set,
Set.
and then we got A complement,
Yes.
and a set intersected with the universal set is
The set
the
itself.
set itself.
Thank you very much. Thank you. So you are actually learning very nice. So yes, this is algebra of sets. Any questions here? Yes.
Just one. Which ones are on the level of the book and which ones are...
None of them. Yes, I told you that university students cannot solve that. Probably it is higher than the level of the book. Okay. Yeah, probably I would say much higher, because that's an abstract notion. That's why I'm saying that they always underestimate you. But for the exam, of course, might be. I have some idea to give some bonus questions with extra points. But then the bad point about that, some people are so ambitious, they want to just jump to that bonus point and then they, I don't know, lose the time for the exam. This is the only downside. But then if you collect some bonus points and if you lose some points, I can add those bonus points at the end. But if you just don't ignore that, you will not lose anything. That is my idea, but I don't know how much I can do that. Any questions? So one of them is left. We will solve it next time together, okay? Any questions? So I want to tell you that next time I will complete what is in the book. It's just probably one session. And then we will practice one session more, and I will give you 1 week to practice. Then we can have a test. So this week is week 36. 7, yes, 37. Let us say that we will finish everything 38. I give you 1 week to practice 39. So week 40 would be a good time.
Yes.
Is that is it good for everyone? Because I don't know about your other exams. Is week 40?
Yes, that's
Okay. But we have 2 sessions. Which day do you prefer? Because the exam would be here. Today is Thursday. I think Thursday is good. What do you have? What lesson do you have after this? When it starts?
10 minutes after.
Okay, so because usually if someone asks for extra time, I will give them unless you have another lesson. And the other one, I myself have a lesson on Monday. Okay, let us see how we can fix this. Thank you very much.